notations, we say that this algorithm runs quickly, this is slow, for this input, this is fast. Those things actually we are discussing. But the thing to say here is how to represent those things. That's what those things in the sense, what is the rate in which the algorithm runs, what is the rate in which the algorithm occupies the memory, everything I need to represent. So that is what we are going to see in this particular module. The most important module of the entire algorithm course is this. For example, if I was there and Murali is also there, if I want to measure the height, I will say, what is your height? I say 160, Murali say 160, 150, like that, right? Then what is that 160, 150? I need to say 160 centimeter, 150 meter, or 6 feet, or 5.55 feet. Like that, I need to express in some unit. Likewise, there should be some unit to represent the time complexity as well as the space complexity. Experts will say that why don't we measure the time complexity and space complexity in seconds or in bytes or so on. Memory can be in bytes, time can be in seconds, minutes, or hours. But we don't do that. Why? Because we are not going to measure the exact time of a program, because the time of the program differs with respect to the input. If my input is very large, it will take more time. If the input is small, it will run in a less time. So I cannot say that this algorithm runs, it takes 50 seconds for this input, 55 seconds for this input. I cannot say like that. I should denote everything through a common terminology as some complexity. So this complexity is this, right? So I want to represent it using those terms. So that complexity notation is actually called as asymptotic notations. Hope you have heard this term already, right? Yes.
Yes, sir.
A representation for time complexity and space complexity for a given problem or an algorithm. Big O. Okay, big O is one of the notation and represented as
Omega.
capital O. Yes, very good. Big omega.
Theta.
Very good,
Theta.
very good. Very good, very good. Who is that? Theta. Theta. And the notations I will write in pen. Okay. Here also, big omega also I'll write using some pen because need some. The omega symbol is not in my keyboard. Okay. And there are also some other things called as little o, represented as small o. First one is little omega, represented as small omega. I'll write the symbols now. Big omega is written as, this is big omega, theta, this is theta, and small omega, the W omega, right? That's it, small omega, right? So these are the 5 different asymptotic notations we have in algorithm, right? So whenever we go for any algorithm, we are problem statement, we must denote the time complexity and space complexity using these 5 notations only. Now, can anyone say what is big O?
Worst case time complexity.
Worst case time complexity. Omega?
Best case.
Huh? Omega is best case, right? Okay, what is theta?
Average case.
Yes, theta is average. Then I'm little o and little omega. Hope you have not seen those things. We'll see that, right? Now we need to represent this big O notation, big omega notation very clearly. So I'll explain that. Right? Big O notation represented as capital O. Now we need to understand this big O notation. Let us have 2 functions. Let f of x and g of x be 2 functions. Let f of x and g of x be 2 functions. This is what I'm taking. Now let me go for a small diagram. Yes. Now I have this f of x and g of x. I can denote the axis as either time or space. And with respect to the inputs, I'm going to draw. So this is actually the input space. Yes.
Sir, sir, there's a lag between you and me, sir. There's a network issue, sir.
Oh, sorry. Hello. Can you hear me now better?
Yes, sir.
Yes. Now I could hear yes quickly when I speak. Yes. Now I connected to another network. Now it will be better, I hope. Am I doing good now?
Yes, sir. Now it's better, sir.
Yes. Thank you. Assume that I'm having something like 5x plus 3. Next, I'm having something like 6x. Now, quickly say me what will be the value of f of x if x is equal to 0.
3.
Three.
3, sir.
If x is equal to, okay, 3. X is equal to 1.
8.
X is equal to 2.
13.
13. So, let us have like this. Now, coming to here, the same x is equal to 0. Here,
0, sir.
x is equal to 1.
6.
6. X is equal to 2.
12.
Yes, so far so good. So now I'm asking you a question. Until x is equal to 2, who is highest?
F of x.
F of x. Good. Now going for x is equal to 3. Now what will happen?
8.
F of x will be 8.
18. Very good. Here coming to x is equal to 3. What will happen?
18.
18.
18. Now who is highest?
Both are
Equal.
Whether
Both are
both are
same.
same functions? Whether both are same functions?
No.
No.
No, no. That's the thing.
no, sir.
Now further increasing. X is equal to 4. 23. Am I right?
Yes, sir.
23, sir.
X is equal to 4.
24.
24.
Now what is the pattern? Now who is highest?
G of x.
G of x.
G of x. We will still move down. X is equal to 5,
28.
28. Like here, x is equal to 5, 30.
30.
Now I ask you a small question. After in future, whether in any point of view will f of x will be greater than g of x?
Yes, sir.
Will be there or not? Whether f of x will come greater than g of x hereafter? If x is equal to 6 or x is equal to 7 or
No,
any other
sir.
point. No, not at
No,
all.
sir.
Not at all. Why? Because until a particular point, we know that f of x is greater than g of x. But after some particular point, we found g of x to be greater than f of x, right? But at some point, we see that sometimes f of x and g of x intersect, and after that, f of x and g of x will never meet. Will never meet. That is the most important point. They will never meet, and g of x will always be greater than f of x. This kind of notation is called as big O notation, right? This kind of notation is called as big O notation. Now I represent this g of x function as, I can say this as g of x can be equal to x. G of x is equal to x, and I can represent let c is equal to 6, and I say c into g of x to be 6x. Now slowly I'm increasing the whole definition. I'm not directly saying the definition. Slowly I'm bringing the entire big O notation, right? Before doing any of these things, we say that f of x and g of x alone, we had two functions. On substituting the input values, x is equal to 0, 1, 2, and so on, if I increase at a point x is equal to 3, I found that both are intersecting. Do you agree on that?
Yes, sir.
Yes.
Yes, sir.
After that particular point, what happens? We know that if g of x trespass to f of x and they will not meet. Now, what I'm going to do is, now I'm going to introduce another paradigm here. That is, I'm going to say g of x is just x, and I indicate another constant variable called as c. Because of that c, we've got this particular curve. Am I making it clear? It is not just because of the function. I have induced another constant c. Because of that, the entire function is actually behaving like an worst case function. That is, g of x is greater than f of x. Right? So far, so good. If I say the definition, it will be even more clear. Shall I go to the definition?
Yes, sir.
Okay,
Yes.
sir.
Now I'm having here, let f of x and g of x be two functions. Then f of x I have to say that f of x is going to be big O notation of g of x if the notation is going to be f of x is equal to big O of g of n, big O of g of n, or I can say f of x is equal to big O of g of x, anything x or n, anything I can use. If you are using n, both it f of n is equal to like this. If there exists some constant c, a constant c, that is, the c is nothing but what? This particular c is equal to 6. Some constant c that is going to be greater than 0, and k, and some k value. The k value is another constant. I'll say what is k value. That is greater than or equal to 0. That is greater than or equal to 0, such that f of n is less than or equal to c into g of n for all c or n greater than or equal to k. We'll write that thing in pen for all. This is a for all symbol you will write, right? That is for all symbol. Or I can write it in symbol itself directly. For all x greater than or equal to k, right? Now I'll take on color, that is yellow will be nice. See, now I'll explain this definition. F of n is equal to big O of g of x if there exists a constant c. My constant c is nothing but here. My constant c is 6. 6 is ready. So I want to multiply that 6 with g of n. Yes, I have done. That is 6x. Next, what I should find, I need to find some k value. After that k value can be greater than or equal to 0. I make c as greater than 0. Why? Because if c is equal to 0, then g of x will become 0. Because I'm going to multiply c with g of x. If c is going to be 0, then g of x also will become 0. So I will not take a value of c that is equal to 0. It should be greater than 0. I need to find a value k in such a way that in that particular, and before that particular k, we can see that f of n is actually greater than g of n. But after that particular value k, we mean that this is actually the k. After k are equal to k, at that particular point we see g of x is going to be greater than f of x. See, c into g of x is going to be greater than f of x. So I can write here n or x, anything can go on. If you are writing x on both sides, write x, or if you are writing n on both sides, you can write as n, right? I will come again. So big O notation is nothing but take two functions f of x and g of x. If f of x is actually initially greater than g of x, we need to find some constant for g of x and some k value in such a way that that constant into g of x will become greater than f of x after that k value greater than or equal after that k value that g of x will always be greater than f of x. This is actually the kind. Am I making it clear now? Yes, am I making it clear, students?
Some are complete.
Yes, it is confusing. Okay, I'll say one more time. Right? Right. Right. So up to this, you have understood this f of x function. You have understood how this
Yes,
f of
sir.
x.
Yes,
Yes.
sir. Yes, sir.
Now we
Understood, sir.
have some f of x function, and how this c came. Have you understood that?
Yes, sir.
Yes. Why we are putting c? If you give me any function, surely that function can. I cannot make that function to be greater than f of x. I need some help. That help is c. For example, you give me two functions, say 5x and 3x. So if I want to make 5x, 100x and normal 2x, we know that after some at any point 100x will always be greater than 2x. Am I right? Always 100x is greater than 2x. How can I make 2x greater than 100x? Only when I multiply any constant with 2x that makes it greater than 100x. Then only I can actually make it, right? So that constant is going to be c. So this is actually clear, right? F of x and g of x, these values.
Yes, sir.
Sir.
Yes. Now coming to this diagram, I'm having two functions. One is f of n going from this f of x that is going like this, and g of x that is going on the other end. Now what we are going to find, see the same thing we have plotted here. Initially we found that this is actually the f of x. Initially we found for x is equal to 0, f of x is actually 3. So it is higher. X is equal to 1. Who is higher? Who is higher in f x is equal to 1?
Yes, sir.
F of X, sir. F of X.
X is equal to 2.
F of X.
X is equal to
F
2
of
also
X.
f of x. X is equal to 3.
F of
F
Both
of
are
X.
same.
both are same.
Both are
Sir.
same.
Both
That
are
is why
same.
that is why this intersection point came. This intersection point came in the that intersection if x is equal to 3. So this point I name it as k value. This point I name it as k value, and k can be equal to 0 also. If k is equal to 0, what will happen? From the starting point itself, g of x is greater than f of x. If k becomes equal to 0, we mean that from the starting point itself, g of x and is greater than f of x. That is the meaning, right? So this is what I fix as k value. Am I making it clear?
Yes, sir.
Yes.
Yes, sir.
Now this function is now going to be not just as g of x. I'm going to make it c into g of x, because of which it is actually being greater. Now if you give me normal 5x plus 3 and the x, at any point of time I cannot make this g of x greater than f of x. Only when I got an help from this constant c, I made this g of x greater than f of x. Do you agree with me? Without this constant, nothing is possible. Am I
Yes,
right?
sir.
Yes. So that only we are actually multiplying, right? So far so good.
Yes, sir.
Yes, sir.
Yes. Now you say me the definition based on this diagram alone. Now let f of x and g of x be two functions. F of x, g of x, two function is there, right? Now what I'm going to take, what is the big O notation? Big O notation says one function is equal to big O of another function. That is called as big O notation. We say f of x is equal to big
Big O
O
of
of g of x. Very good. F of x is equal to big O of g of x. If this should be happen, what I should do? If
constancy.
there exists, very good, there exists a constant c, whether c can be equal to 0?
No,
No, sir.
No, sir.
No.
Greater
Why?
than 0.
Why? If it
It
is
is
0,
0.
then g of x will become 0.
If it is 0, G of X also 0.
Exactly, very good. So I will take c greater than 0. I should not put greater or equal to. If I put equal to, g of x will vanish. And I should take another value called as k. What is that k value? After that point
Greater than or
only,
equal to.
g of x will be greater than f of x. K can be greater than or equal to 0 also. If a k is becoming 0, what will happen? From the initial point onwards, g of x will be greater only, right?
Yes, sir.
If there exists a constant c greater than 0 and k greater than or equal to 0, such that f of x is less than or equal to c into g of x for all k for all x greater than or equal to k. Actually, this is actually the x. I'll name here. I'll go here. This input is there now. This is actually meaning x. This is actually x. For all x after k, that is x greater than or equal to k. After k, if any x value comes, for all those x values, if I see g of x is greater than f of x, g of x is greater than f of x, and it goes on. At any point of time, it will not. It will be going like this only. At all the time, g of x will be on top and f of x will be on bottom. Right? Is it good now? Or shall I say one more time?
No, sir.
No, sir.
Yes,
Good.
crystal clear, right?
Yes, sir.
Yes.
Yes, sir.
So this is actually called as big O notation. Now, still that definition is there, explanation is very good, no issue. But how it is actually related to algorithms? Now, initially somebody said that big O is called as worst case. Why the definition is worst? No, it is called as worst case. Why? Because we say if the time is higher or space is higher, then we say it is called as worst. If I was able to finish a particular job in less amount of time, then I will get a name as best. If I finish the same job in higher amount of time, then I get a name as worst. So now whether C into G of X is good person, that is best person, or worst person.
Worst.
Worst.
First.
Why? Why? Because he completes the
Eight.
job in higher
On.
amount of time. Why we are making C into G of X as worst? I am creating a bound. This is called as asymptotic bound. That is not as another name for asymptotic notation is asymptotic bound. So what is the bound is? I am saying that my original function of my algorithm is f of x only. For that f of x, I am putting a bound here. So what is that bound? I am saying that this f of x will never go higher than this particular bound. Very simply, if I want to say, I give you an algorithm and say that this algorithm will not run for any inputs more than 10 minutes. Maximum it will take only 10 minutes. More than 10 minutes it will never take. That's what I'm saying. Another example, what I can say is, if I coming to second year E section for taking algorithm class, and I was being asked, what I will be thinking is whether I will be thinking that there are two ways of thinking. You say me what I should think, how many S grades I can get. I should think like that, or how many pass percentage I can get. That I should think. What I have to think first.
Pass percentage.
Yes, why? Because pass percentage means that the overall quality of the class. S grade means that the quality of one particular student. So, in the entire quality of the class, I need to think. I should not say that this class can get 5 S grades, but 16 people will fail. That I should not think. I should not say. It will not be nice. Instead, what I have to say, this class will not get more than 3 failures. This class will not get more than 1 failure, or this class will not have any failures. That's what the better way of saying. That is worst case of the class. Beneath this worst case, it will never go. That's what the worst case complexity is. Am I making it clear now?
Yes, sir.
So what is the worst case of f of x? The worst case of f of x is c into g of x. After above c into g of x, f of x will never go. That's what the big O notation says, right? So now an important point to note here, most important point when MCQ perspective everything. So I'll write that in red color. Big O notation is called as tightest upper bound. It is upper bound because g of x in the upper end, right? So it is called as tightest upper bound, right? Or worst case time complexity notation, right? So big O notation is called as tightest upper bound or worst case time complexity notation. This tightest means a lot, right? This tightest means a lot. Using this tightest only, I'm going to give the definition for little o, right? So what is big O notation? So what is big O notation?
Tightest upper bound.
Tightest upper bound or worst case time complexity notation. So the formula is f of x less than or equal to c into g of x. Right? This is the thing for all x greater than or equal to k. Now shall I move into big omega?
Yes, sir.
Yes, sir.
Yes, shall I erase this? You can take the screenshot. Yes, shall I erase?
Yes, sir.
Yes, sir.
So now I'll go to the big omega notation. Second is big omega notation. And as you said, big omega notation is called as best case time complexity. Omega notation. This is omega notation. Right. Now can you say me the definition? I'll draw the diagram, right? You say me the notation. Or you also help me in drawing the diagram. Exactly simple as big O, but in the opposite case. I write here the inputs. These are the inputs. And what will come in the y axis?
MR space.
Time or space. Very good. See, my handwriting is going like anything. Please bear with me. It is whether it is understandable.
Yes, sir. Understood.
Yes, sir.
Thank you, thank you, thank you, thank you for support. Now I need to have two functions. Let f of x and g of x will be two functions. The same blah 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 will come. So now what I will have to write here? I need to draw f of x and g of x. The drawing is something different. Now I'll draw f of x like this. This is my f of x, and my g of x will be, and I'll write here f of x. This is, I will make it somewhat large also. This is my f of x. And I need to draw the g of x now. I'll take the g of x. G of x will be initially higher than f of x, and after some point of time, it will become lower. What is this? Some c into g of x. Now you know what is c and all, right?
Yes, sir.
Yes. After giving the c value, it will be somewhat lower, and this is f of x is and this g of x c value. And what is this? This intersection.
Okay.
Yes, sir.
Okay. So initially, f of x may be greater than g of x, but after some point of time, that is k, f of x will be greater and g of x will be smaller. So we may take k as some reciprocal values also. So this is actually the notation, right?